Morning, sir. My name is S.A. and my roll number is 2340180 from Department of ECE. Today, let us discuss about comparison of PAM, PWM, and CPM. Differences in performance, bandwidth, and noise in unity in analog and digital circuits. Introduction of the PAM, PWM, and PPM. The modulation techniques are classified into major two types, analog and digital or pulse modulation. We have discussed previously the different types of modulation techniques. Let us understand basic differences between PAM, PWM, and PPM. PAM is abbreviated as a pulse amplitude modulation and PWM is a pulse width modulation and PPM is a pulse position modulation. These are the mainly types of the pulse modulation. Here we can see the definition of a pulse amplitude modulation PAM. By varying the amplitude of the pulses, that nothing but carrier signal is proportional to the instantaneous value of the analog signal, that is message signal. This is called the definition of the pulse amplitude modulation. Here we can see the waveforms of the pulse amplitude modulation. Pulse width modulation. By varying the width of the pulses of carrier signal is proportional to the instantaneous values of the analog signal. These are mainly consist of three types of PWM. There are the leading edge of the pulse being a constant, the trailing edge varies according with the message signal. The trailing edge of the pulse being constant. The leading edge varies according to the message signal. And third type is the center of the pulse being constant, which can be leads the edge of the trailing edge varies according with the message signal. These are the waveforms of the pulse width modulation. Next, we can see that pulse position modulation, PPM. By varying the position of the pulse is proportional to the instantaneous value of the analog signal. Pulse position modulation is done in accordance with the pulse width modulation modulated signal. Each trailing of the pulse width modulated signal becomes the starting point of the pulses in PPM signal. These are the block diagram of the PAM: encoding, bandwidth, noise immunity, implementation, and application. Encoding is a process of encoding by varying amplitude of the pulses. Bandwidth, which requires bandwidth, is compared to wider PWM than PPM. Noise immunity is generally more when compared to PWM and PPM. At implementation, PAM is relatively simple implement. This PAM is widely used in communication systems. PWM, which encodes that information is encoded by the varying the width of the pulses while maintaining a constant pulse amplitude, and its bandwidth is very less when compared to PAM. Noise immunity of PWM is more immune to noise than PAM. Implementation is PWM is relatively simple to implement. These are the mainly applications used in DC motors, digital to analog converters. BPM, which can be encodes the information by varying the position of the pulse, which relates to reference time, while maintaining constant amplitude and width. Bandwidth is the PPM is requires large bandwidth than PWM, but less than the PAM. Noise immunity is of PPM is more immune to the noise than PAM. We can implement PAM is more complex to implement the PAM and PWM. These are used in many applications like some optical communication systems, etc. We can see the comparison of PAM, PWM and PPM. The parameters PAM, PWM and PPM. The type of carrier in PAM, PWM, PPM are seen. That's nothing but train of pulses. And its characteristics of PAM is amplitude, PWM is width, PPM means position. Bandwidth of the PAM is low, PWM is high, PPM is also high. Noise immunity PAM is low, PWM is high, and PPM is also high. The information contained PAM, which contains amplitude variations, PWM contains width variations, PPM, which contains the information position variation. Transmitted power is uh, power efficiency is low, moderate, and high in ppm. Transmitted power, which can be varies between amplitude of the pulses, which varies between width, it can be remains constant in ppm. Needs to transist synchronized pulses, not needed in ppm. PAM and PWM. PPM is must be necessary required for transmit synchronizing pulses. Bandwidth of the PAM is which depends upon the width of the pulses, and PWM is also which depends upon the rise time of the pulses, and PPM is which depends upon the rise time of the pulses. Complexity generation. In PAM, it is very complex. PWM is easy and PPM is complex. We can see that similarity of the other modulation system. PAM is similar to AM, PWM is similar to FM, PPM is similar to AM. We can see that conclusion in comparison of PAM, PWM and PPM for analog and digital application. PAM modulates amplitude, PWM modulates pulse width, PPM modulates pulse position, each with varying bandwidth, noise sensitivity and complexity. In PWM is often favored for digital applications due to efficiency and control, while PPM offers advantages in specific analog scenarios. Thank you for giving this opportunity.